Welcome back, everybody. In this video, we'll be working on the start of section 10.3, which is about our last conic section that we'll look at, the parabola. So the approach for this section is we'll take a look at just what the geometric definition of the parabola is. We'll come up with the equation of a parabola. Like the ellipse and hyperbola, there will be basically two forms depending on how the shape is oriented. And we'll see how to come up with the equation for a parabola given some of the information about the parabola, and we'll also see how to produce the graph. And then we'll see an application along the way. All right, so let's go ahead and start. So in terms of the cone picture that we've been starting each of these with, a parabola is made when you take and form the intersection or cross section of the nose-to-nose cone shape with a plane that is not parallel or perpendicular to one of the bases of the circular cones. So that results in a parabola. We have graphed parabolas as quadratic functions before. In your algebra life, you've graphed things that look like f of x equal ax squared plus bx plus c, the most basic of which is y equals x squared, a parabola with vertex at the origin. In this section, we're looking at more of those, okay? So in terms of point sets, a parabola is a set of all points in the plane that are equally distant from a fixed point F, called the focus, and a fixed line L, called the directrix. So if you have a point in the plane and then a line, then the set of all points that are equally distant from the point and the line are going to make up a parabola. As shown in the picture right here, so the kind of red curve is going to be our parabola, and we have this point F, the focus, kind of in between or inside the parabola, some people will say, and then the horizontal line down here will be our directrix. The important piece of the definition is that that distance between the focus to the parabola and the parabola to the directrix is the same. And notice that if you take the vertex of the parabola as one of those points, that means that the vertex for the parabola will be exactly halfway between the focus and the directrix. All right, so elsewhere on the graph, we can see that, for example, here, that distance from the focus to this point on the parabola is the same as the distance from this point on the parabola down to the directrix. So that is the kind of definition in terms of point sets. So what we'll work on next is actually do the derivation for the equation on the parabola. And to do that, I wanted to remind you about the distance formula. We looked at that recently, but it's worth repeating. If you have points x1, y1, and x2, y2, how to find the distance between the two. Basically, we saw that we could come up with this formula using the Pythagorean theorem. The change in x is x2 minus x1. The change in y is y2 minus y1. If we use a Pythagorean theorem and think of the hypotenuse as that distance we seek, we end up with this distance formula you see here. Square root of the change in x squared plus the change in y squared. Okay, and so we'll use that distance formula here in just a minute to help us produce the equation for that parabola. So like right now. So we're going to do this for a parabola that opens up and down. In this section, we'll also treat parabolas that open sideways. But first, we'll come up with the equation for a parabola that opens up or down like this. Okay, so the thing is, based on the definition, we have this parabola. We're going to situate it at the origin so that its vertex is at the origin for now, and opening upward, as I said. So the directrix will be in the lower half plane. Its equation will be y equals minus p. Here, p is positive, and it is the y coordinate for our focus. Right, the vertex is at 0, 0. So the distance, two distances shown here marked as d, from 0 to 0p to the point xy on the parabola, that distance is the same as the distance from xy down to the point xp on the directrix. So what we're going to do is, by definition, those two distances marked as D have to be equal to one another. So we'll set them equal to each other, okay? So the upper one, that one, distance formula between 0p and xy. So a change in the x direction will be x minus 0. That's squared. And then the change in the y direction is y minus p. That's squared. We'll take the square root of that. That's the first of those distances. And then the second one, the distance from the point down to the x-axis is y, right? Then we're going further. We're going down to minus p, right? And so this distance is p. So altogether, that distance is y plus p. Okay, so then the second distance is y plus p. Our first distance is this radical. So that is an equation that involves x, y, and p. So we're going to simplify that sum, and we'll see that that will turn into the equation of a parabola for us. So let's just focus on this, as it were. So get rid of the radical. We're going to square both sides. So let's do that. So let me show that. Yeah, let's do that as a first step. So let me rewrite this just one time, showing the radical or both sides being squared. Okay, so we want to square both sides so that that will remove the radical for us. So we'll have x minus 0 squared plus y minus p squared is equal to y plus p squared. All right, so then x minus 0 squared is the same as x squared. And then this y minus p squared, we're going to go ahead and multiply that whole thing out. So that will give us y squared minus 2py plus p squared. And then the right side, we'll do the same thing. We'll have y squared plus 2py plus p squared. Okay, so taking a look at that, we can see that the left side and right side both have some terms in common. Both of them have a, let's go a little lighter. Both of them have a p squared. So we'll be subtracting that from both sides. They also both have a y squared. So we'll be subtracting that from both sides. We'll have x squared minus 2py is equal to 2py. And then we're almost there. It's customary for equations of the parabola to isolate actually the x squared term. So we're going to add 2py to both sides. So we'll have x squared equals 4py. Okay. And that's our equation for a up-down opening parabola. If it opens sideways, as we'll see, you could go through a similar direction for a parabola that opens sideways, and you will get y squared equals 4px. If you feel like it, if this stuff interests you, then feel free to go ahead and derive that formula. But the steps will play out very similarly. So this is the equation for a parabola that is centered at the origin and opens upward. The p is sitting here in the equation. Notice that that p is the distance from the origin. Vertex for now is the origin. Distance from the origin to the focus, and the p is also the distance from the origin to the directrix. Okay. So let's see what we can do with that. So repeating the some of the facts here, just to summarize, x squared equals 4py is our parabola with vertex at the origin. And the focus is at 0p. Notice the x coordinate 0, so it has to be along the y-axis. The directrix is a horizontal line, so its equation is y equals something, and it'll be y equals minus p, because p is positive. P is along the positive. If p is along the positive y-axis, then minus p will be negative. Okay. Whether the parabola opens downward is determined whether the p is positive or negative. If p is positive, it opens up. If p is negative, it opens down. Okay. So now it's ready to start trying some examples. So let's do that. So for this one, we're to find the equation of the parabola that has a focus at 0, 4, and the directrix at y equal -4. We want to sketch a graph. Okay, so you may want to do the graph before or at the same time as finding the equation. So for now, we're going to just assume that the vertex is at the origin. And so if the focus is at 0, 4, and the directrix is y equals -4, the grid there is actually kind of disturbing. The labels are not quite on. All right, so there is our directrix. So the parabola has to open upward, right? So the direction of opening will always be in the opposite direction of the directrix. So this one has to open upward. So it will be x squared equals 4py. And basically our p is the distance from the vertex to the focus, or equivalently, the distance from the vertex to the directrix. And so that has to be 4. Okay, so p equals 4 in this problem. So x squared equals 16y. Okay, so that's it for finding the equation. And then we want to produce the picture. So let's do that. So I know it passes through the origin. And then we just need to get some other pair of points for the graph. I know that the y-axis will be an axis of symmetry for this thing. So if we can find just one point, then that will be okay. So I want to try to think of an x and y pair that will fit on here. Of course, the coefficient of y is 16, so that's kind of larger. So I want to think of something that will make a nice perfect square for us. So if we take y to be 1, then the right side would be 16. The left side, we could make that 16 also by choosing x to be 4. Okay, so the point 4, 1 should be on the graph. Okay, so if we go 4, 1, that's on the graph, and then also -4, 1 should be on the graph. So this parabola opens kind of like that. Okay, so we found the equation of the parabola and then also sketched its graph. Okay, all right, this time we're going the other direction. This time we have the equation for the parabola and we want to find the focus and the directrix. Okay, so here, again, if you wish, a sketch can help you with this, although in this example it's not required. We have x squared equals -12y. So what I would probably do is rewrite that as x squared equals 4py so that we can see what the p is. So then x squared, how can I think of -12 as 4 times p? This will be 4 times -3y. Okay, so that helps us recognize that the p is -3. And if you like, a sketch here is going to help you. So this one, the x squared is always positive, right? So let's think for a minute. Take a look at the equation. For thinking about the direction of opening, x squared is always positive, right? No complex numbers in this whole chapter, okay? X squared is always positive. So the right side, -12, is negative. If the left side's positive and the right side has -12 multiplied by y, then doesn't that mean that y has to be negative if the left side is positive? And sure enough, it does. And so our parabola has to open downward. Okay, and so that means that our focus is on the negative y-axis. The x coordinate will be 0. The y coordinate will be our p, which is -3. Okay. And then for the directrix, remember the directrix here is going to be a horizontal line. And it will be y equals, and it's going to be positive 3 because it's on the other side of the vertex, right? So that will have to be y equals positive 3. Okay, so we found the focus and the directrix for our parabola. All right, so let's continue by taking a look at parabolas that open sideways next. So here's the basic facts about side opening parabolas. Their format for their equations is going to be y squared equals something. Y squared equals 4px. When the y is squared, they're side opening. If the x is squared, then they're up-down opening. We don't usually focus on side opening parabolas as much because they don't really represent y as a function of x. Okay, vertex here is going to be at the origin for the time being. The focus will be at P0. Notice that for the focus, the x coordinate is P, the y coordinate is 0. Okay, if the y coordinate is 0, that means the focus is on the x-axis. If the focus is on the x-axis, it has to be side opening. Okay, the directrix is x equals minus P. So notice that it's x equals, making it a vertical line. It has to be a vertical line if the parabola is side opening. And notice that the sign here is opposite the sign of P, right? Because the focus you can think of as kind of inside the parabola. So the directrix kind of has to be on the opposite side. Okay. The parabola opens to the right if P is positive, and opens to the left if P is negative. If you forget that, we can always just kind of reason it out and think about what the signs have to be. Okay, so we're going to try an example next. We want to find the equation of this parabola, and the vertex is at the origin for now. The axis of symmetry is going to be the x-axis, and the graph contains the point -1/2, 2. Okay, that is, it'll pass through that point. And then we'll also want to find the focus and directrix. Okay, so even if a graph is not explicitly requested, it can be a good idea to make even a rough sketch of a graph to help you answer the question. So let's think about what has to be. The vertex is at the origin. Okay, we need that. The axis of symmetry is the x-axis. Sorry about that. Switching off. Okay, the axis of symmetry is the x-axis. So if it's going to be symmetric across the x-axis, then that means it has to be side opening. If it contains the point -1/2, 2, okay, that point is going to be on the parabola, then it has to open to the left, right? Sorry, my scale off. Okay, it has to open to the left if it's got the point -1/2, 2 on it. Okay, so then I know that it's going to be y squared equals 4px. Okay, so you got to think about, well, where's the focus going to be? The focus is inside the parabola, so it's going to have to be a negative value for p. And so p will be, well, we've got to figure that out, right? So how can you find the p? How we're going to find the p, the only other piece of information we have is the fact that this thing passes through the point -1/2, 2. So we'll replace the x by -1/2 and the y by 2 and solve for p. Okay, looks like our p has to be -2. So replacing that into the equation, y squared equals -8x if p is -2. We found the equation of the parabola, so that part's done. And we also wanted to find the focus and directrix, so let's do that. So the focus is on the x-axis, so it will be -2, 0. Notice that that's a point. So I'm putting in -2, 0 in parentheses, not just -2, okay? The directrix, will that be horizontal or vertical? Directrix will be vertical. Since it's a vertical line, it's going to be x equal, and it's in the, passes through the first and second quadrant, it'll be +2, x equals +2. Okay, so we got the equation of the parabola and then also its focus and directrix, which is what we needed. Okay, moving along a little bit. Okay, another kind of definition. So every parabola has a latus rectum. That's a Latin phrase that means straight side. The latus rectum of a parabola is a line segment that passes through the focus and is parallel to the directrix. So it's a line segment that goes through the parabola, through the focus, but is parallel to the directrix. Its endpoints, we'll talk about the distance of the endpoints in a second. So that line segment parallel to the directrix passing through the focus. If you consider the segment or piece of it that has its endpoints on the parabola itself, that makes the lattice rectum, and its length is going to be called the focal diameter for the parabola, and it's always equal to 4p. So that's kind of interesting. So we want to think about why that's true. So taking a look at the picture here to your right, based on the definition for the parabola, the distance between the point Q, let's say, between the point capital Q and the directrix, that distance has got to be the same as the distance between that point and the focus, based on the definition of a parabola. If we've located our vertex, our parabola, so that the vertex is at the origin, then P is the distance from Q to the origin, from Q to the y-axis, the way that it's drawn here. And so the distance from the y-axis back to the directrix is another P. So that distance from Q to the focus has to be 2p. Since the focus is on an axis of symmetry for the parabola, the other half has to also be 2p. And so the whole lattice rectum has to be 4p in length, which is pretty neat because our equation has either a 4px or a 4py in it. So try a little example. So here it says for the parabola y squared equals 8x, find the focus, directrix, and focal diameter. Let me do the focal diameter first, just because we're just talking about it. Focal diameter is 8. Okay, that's, you can read that straight off the equation. Remember that the equation is y squared equals 4px. And if the focal diameter is 4p, then it's right there in your equation. Okay, here it's 8. Okay, and so for the rest of it, we want the focus. So this one is y squared, and so the parabola will be side opening. I know it opens to the right because y squared is positive, 8's positive, and so x has to be positive. If x is positive, my whole picture has to be in quadrants 1 and 4. So it opens to the right. So then if we want the focus, it will be over here. And the equation is 4p. 4p equals 8, right? If 4p is equal to 8, p is equal to 2. So the focus is at 2, 0, and the directrix will be x equals, because it's vertical, x equals -2. All right, so this has been the first part of our video on parabolas. We're going to continue looking at some more examples in the next one. Let me know in the meantime if you have any questions, and have a great day.